everyone, and welcome to lesson number 12 of the Operations on the Real Numbers course. I'm Mrs. Cofield, and today I am delighted that we're going to be discussing multiplying decimals, and we're also going to talk about scientific notation. Okay, guys, let's go! Now, for the last couple days, we've been talking about the main principle of multiplication, and it states that you can multiply anything times anything. And I always say that is great news because this is way simpler than our addition when we had to get a common denominator and subtraction. Because again, you're multiplying anything times anything. So for example, with fractions, we just multiply straight across. It was so easy, right? So let's see how it relates to decimals. So when we're multiplying decimals, considering what we just said, do you think that we can multiply 3 and 1400ths times 2 and 1/10? Absolutely, yes we can. But just think about how we used to add and subtract decimals. Usually we line up the decimal point. Do you think that that's something we have to do here when we're multiplying? Must we line up the decimal points? No, you don't have to line up the decimal points because you can multiply anything times anything. So it's not pertinent that you have to multiply tenths times tenths and hundredths times hundredths. No, in this case, anything goes. You can multiply anything times anything. All right, so let's talk more about it. Let's say that we have 2 and 3/10 and we want to multiply it by 5100ths. Okay, so we go ahead first of all and we multiply as usual. And we go through all the regular steps of multiplication. And when you get your final answer, then I want you to stop and think, where do we place our decimal? Go back to the original problem and count how many digits are there behind the decimal place in our original question. Altogether, there are 1, 2, 3 places behind the decimal. That means that there should be 1, 2, 3 places behind the decimal in our answer as well. So our answer is going to be 1 and 173 thousandths, just like that. So again, just add up the amount of decimal places to the right of your question, and then that's how many should be to the right of your answer. Make sense? Let's go to another example. But before we do, here's a special note. Now when multiplying, always check the reasonableness of your answer by estimating. So let's say we have 2 and 3/10 times 4 and 1500ths. Now again, we start by multiplying as usual. Remember, you can multiply anything times anything, so you don't have to line up the decimals. We just do it as we usually multiply. And then this is the answer that we end up with. But then the question arises, where do we place our decimal, right? So we go back in, and just as I said, let's start by adding up the number of digits to the right of the decimals in our question. That's a total of 3 digits. That means there should be 3 digits behind the decimal in our final answer as well. And that is true. We end up with 9 and 545 thousandths. But now, let's apply what I just said as far as estimating our answer and checking it for reasonableness. Was this question reasonable? Well, let's estimate. 2 and 3/10, what whole number is that close to? Yep, you got it. That's approximately 2. What about 4 and 1500ths? What whole number is that approximately? Yes, that's approximately 4. So if we just think about basic mathematics and we estimate it, 2 times 4 is 8. So when I say check for reasonableness, we're comparing where the decimal place is at right now. And right now it's behind the 9. So, it's somewhere close to 8, a little more than 8, right? And we're at 9.5. That's way better than if we were to estimate and say 95.45 or 954.5. Now that, in those cases, we'd be in trouble, right? So again, think about those whole numbers that they're close to and approximate, round it, and then multiply and check your answer for reasonableness. Okay, Great work! There's another fact that I want to make sure that you have in your notes. So make sure that you write this down. To multiply decimals by a number in the tens family, just move the decimal point to the right, the number of places equal to the number of zeros in the power of 10. Now I know that sounds like a lot, but I'm going to show you what I mean. I'm telling you, it's way simpler than it sounds. It's so simple that the instructions say multiply and you don't even have to show any work. That's very simple. Watch this. 1,000 times 37 and 1,489 10,000ths. So, what this is telling us is that we need to multiply this decimal, but do we have to show the work the long way that we're used to doing? No. There's a shortcut. Watch this. All you have to do is go in and count the amount of zeros that are in 1,000. That's 3 zeros. And that number 3 is an indication of how many places that we have to move our decimal place to the right in our answer. So watch this. 1, 2, 3. That means our decimal needs to be between 8 and 9. So our final answer is 37,148 and 9/10. You see that? The 3 zeros and that power of 10 tells us to move our decimal place 3 places to the right. And that's it. Let's try another one of those guys. I told you it was way simpler than it sounded. Now we have 100 times 2/10. So, again, same type of process. Let's go on in and count the amount of zeros that are in 100. There are 2. There's 2 zeros in the number 100. So, we're going to take our 0.2 and we're going to move our decimal place 2 places to the right. So let's go. 1, 2. The decimal place goes here. Now, in a case like this, what do you all think that we can put in that extra loop? Because there's like a little gap right there. If there's nothing there, we can add a 0. So in reality, if you moved over 2 places to the right on a number like 2/10, what we end up with is the number 20. In other words, 20.0. But we don't even have to say 0.0. Just know that there's an imaginary decimal at the end of that. And 20 is that number. In fact, for all whole numbers, you can look at it like that. There's like an imaginary point at the end and a 0 right there. Okay? So, now that we've done that, we've done decimals, check. We've talked about the tens family, check. And we've also multiplied using exponents, check. And that was a couple lessons ago. Now that you know how to multiply all these things, we're going to do something fantastic. Something that's going to involve all 3 of these in the same problem. I'm talking about we're going to be multiplying with decimals, the tens family, and exponents all at the same time. Watch this. This is called scientific notation. Now, scientific notation is the number between 1 and 10 times the power of 10. Let me give you an example. We're going to multiply 4 76/100 times 10 to the 5th power. Now, we know that 10 to the 5th power, after we've done exponents, is really the number expanded with 5 zeros, right? That's the amount of zeros that we have. So that's 100,000. So in other words, we're doing 4 76/100 times 100,000. Now, when you also think about that 10 to the 5th power, what we used to do with the exponents, the long way was to say 10 times 10 times 10 times 10 times 10. But don't forget, this shortcut right here exists where we know that that means that there's 5 zeros at the end of that number, okay? And in our last example, we just found out that the amount of zeros tells us how many places we need to move our decimal place to the right. So that means we need to move our decimal place to the right how many times? 1, 2, 3, 4, 5 times, okay? So if we do that, we end up with 476,000. Do you need an illustration of what that looks like? If we have 4.76 and we moved it 5 places, that's 1, 2, and that's 3, 4, 5. So we ended up having to add those zeros in there like that. And that's how we end up with that 476,000. Great work. Y'all want to try another one of those? Okay, let's try another example. But this time, this is going to be a real world example. There's nothing like looking at these type of mathematical problems, but in real world situations. So it says, an astronomer discovers an object that is 2 in 1700ths times 10 to the 8th power light years from Earth. What number is that? Well, let's set it up and let's expand it. We know that 10 to the 8th power, it usually has 8 zeros, right? So that number ends up being 100 million. So what we're really saying is 2 in 1700ths times 100 million. But again, those 8 zeros tell us that we need to move our decimal place 8 places to the right. Like loop-de, 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 loop-de. And once we do all those loops and move it to the right, we're going to end up with 217 million. That was beautiful, guys. All right. So this was fun. A lot of fun to talk about multiplying decimals and scientific notation. I hope that you gained a lot from this and that you can apply it even to those real world situations. Okay? So we look forward to seeing you tomorrow. Have a wonderful day and keep up the great work. Bye.